Hey guys, my name is Trevor Sullivan, and welcome back to my video channel. Thank you so much for joining me on my video series where we are talking about Rust programming and how to accomplish a lot of different common tasks using the Rust programming language. Now, if you want to build a command line tool, something like maybe kube control to manage a Kubernetes cluster, or something like the AWS CLI or Azure CLI tools to manage cloud resources, then you'll need to be able to parse what are known as command line arguments. These command line arguments are basically any values that we pass into our software tool, regardless of whether it's Rust or some other application. We're basically just at a terminal, we run a command, and then we specify a whole bunch of arguments or parameters to control exactly how that software behaves. So we can actually take a look at the Rust arguments by using some of the built-in types. And I actually just did an earlier video that covers how to use the Rust standard library in order to interact with command line arguments. But there's a lot of things that you need to kind of consider when you are parsing these command line arguments. So oftentimes it can be really helpful to actually depend on an external crate where somebody else has done the heavy lifting work of parsing these command line arguments and kind of interpreting them, validating them, printing out help for them, giving them aliases so you can refer to them by different names and things of that nature, and even building a hierarchy of subcommands. If you look at a tool like the AWS CLI or the Microsoft Azure CLI, for example, there are lots and lots of different service teams within those organizations. And so their CLI tools have to be kind of broken down into these child contexts or these child commands that focus on individual services within each of those cloud ecosystems. And if you are building a CLI tool, you might want your users of your tool to be able to kind of drill down into different contexts so that they can manage whatever kind of resources it is that your application is helping them to manage. So in order to accomplish this, we're going to be taking a look at this crate called clap here. We're going to be taking a look at how to actually use this library, at least at a basic level, to define some input arguments, as well as subcommands inside of a CLI tool that's written in Rust. And we'll take a look at some of the constraints that we can put around these arguments as well. Because like we talked about just a second ago, validation is one of those things that we generally need to do inside of CLI tools. We need to make sure that whatever input is being provided by the user actually matches the expected input so that we can use that data inside of our application. So what we're going to do is install the clap dependency or the crate using cargo into a brand new project. And we need to make sure that we activate the appropriate features as well. If we drill into one of these tutorials here, you will actually notice that this macro right here called the command macro actually requires this feature that I don't think is installed by default called the cargo feature of the clap crate. So we need to make sure that we install that. And I did want to mention that there's actually a couple of different approaches to building CLI tools with the clap parser here. One of these mechanisms is called the derive pattern, where you define your structs here with all of the different fields that you want to use as input parameters. And then you use these different attributes like deriving a parser. Then you use this command attribute to declare different kind of metadata about your application. Then we use derive subcommand. And I tried this route and I found that it was a little bit messy. It was kind of hard to work with. So in general, especially if you're new to Rust or programming in general, or if you're new to clap, then I would generally recommend going with this builder approach, because this is it allows you to use kind of a fluent API where you can create a high-level command, and then you can start to define your commands, your command groups, your validation rules, and your aliases and all that kind of stuff on a method chain. And it does look a little bit messy at the end, but it's actually a much nicer way of declaring your CLI arguments and subcommands and all that kind of stuff, right? So I would recommend going with this builder approach rather than the derive or attribute approach for starters. But then once you kind of get more adept with the clap crate, then you might want to go back and actually take a look at the derive mechanism to see if that's actually going to work for you. So the way that we're going to kind of kick off our application here is to install clap, and then we are going to use this command macro right here, and this is going to initialize our high-level command that we want to write. We can break that down into additional subcommands as well, or we can just define top-level or kind of root-level arguments by just using the arg method here to declare new arguments. There is an optional macro here called the arg macro that you can use to create new arguments, but I actually personally prefer to use the arg type and then just call the new method on it, and that allows us to instantiate an argument using a slightly different mechanism. Also, you can see right here the top level command that's created through this macro here also has a subcommand method that allows you to define subcommand contexts. So if you're working with AWS, for example, you might define a S3 subcommand or an EC2 subcommand or a VPC subcommand, or maybe you are building a CLI for a department store, right? I'm not sure why you do that, but if you think of a department store, there's men's shoes, there's women's shoes, there's kids clothing, there's men's clothing, there's winter wear for women and things like that. So you can kind of think of those child contexts as different kind of resources that you want to be able to drill down into and then implement the behavior for. Now, once we've defined all of our input arguments and any subcommands that we want to provide to our users, we can call this function here called getMatches on the top level command that we get back from this macro. When we call this getMatches function, that is actually going to pass in all of the CLI arguments that were passed on the command line that you would typically get from the standard crate under the env module, and it will pass them into the parser for clap, and then clap will basically take a look at all those arguments, it'll do the validation, it'll kind of group them together, it'll look at the help documentation for them, it'll look at any aliases that you've declared on your parameters, and it'll provide a result that you can then drill down into to get the underlying values from the command that was ultimately executed by the user. So this getMatches result is what we want to capture into a variable so that we can inspect that later on and actually extract some values out of it. So we're going to go ahead and take a look at how to build a simple application completely from scratch with the clap library here. But before we get into that, I just wanted to encourage you to go over to my YouTube channel. Since I am an independent content creator bringing you these video tutorials, it really helps me if you subscribe to the channel, if you like the video, if you engage by leaving a comment down below. Just let me know what you think of this video series and let me know what other kind of Rust topics you want to see in the future. Your support really means a lot to me, so thank you so much. All right, so let's go ahead and build a sample application here. We're going to start completely from scratch, so I'm going to create a new directory on my Linux server here. Let's just call this my clap test, and then I'll go ahead and just open that up. I'll do Control-K, Control-O in VS Code, and I'll open up that project folder in my VS Code editor here. And yes, I trust the author because the author is me. And so now I'll just go into this directory in the terminal and we'll just say cargo init, and that'll create our application stub. Now in cargo.toml here, of course, by default, when we stub out a new project, we don't have any dependencies in here. So we need to bring in clap for starters from the crates.io registry over here. And so we can just do a quick search for it. And here it is. And we can see that the latest version was recently released about 9 days ago. And so that's the 4.4.2 release. And there's a whole bunch of features that are exposed by this as well. So let's go ahead and do a cargo add clap command right here. As you can see, some of the features right here were added in the default feature list, but the feature that we need in order to use the command macro is actually not available by default. So we'll just rerun cargo add clap and then do -- features equals cargo, and that should include that cargo feature in this crate so that we can use that command macro. So now back in cargo.toml, you can see that a specific version of clap has been pinned to our dependency list, and we've also included a non-default feature of cargo. All right, so now that we've got our dependency imported, it's time for us to start actually using it. So what we want to do is start out by using the clap framework here. And we are going to be using the command macro here. So if we do command like this is going to use clap command factory. And this is or actually it's right down here. Sorry, this is the function. This is the macro right down here. And so this is going to allow us to instantiate a new high level command. Now, if we just do a period after it, then we should be able to get some auto completion here in just a moment. Let's actually just go back and do that one more time with command. And so we need to import the command lowercase c type here, and hopefully that will give us our auto completion in VS Code. So we'll do a new command dot, and now you can see all of this auto completion here. So we can just start typing something like subcommand or do .arg and define a new argument or things like that. We can also define groups of arguments. So if you have certain arguments that are logically combined together, like maybe a first name and a last name to maybe register a person or something like that, then you can actually create groups by doing it .group and then instantiating a new group and passing that into the command. But I want to start out kind of with the most basic level of defining an argument, which is a positional parameter. So what we'll do is just create a .arg here. And inside of .arg, we're going to go ahead and just create a new argument by doing arg, and we'll tell it to use clap arg. So that'll import this capital A arg type here. And then we'll just do :new. And then we need to specify an ID for the new argument. Each argument that you define in a clap program needs to have a unique identifier so that when we retrieve the value of that input argument, we know how to reference that specific argument. So I'm going to call this, how about, let's do first name for now. And then we'll just assign the result here. We'll say let match result equal that, and then I'll just delete this print line hello world down here, and let's see what happens. So let's do a cargo run really quick, and we're going to build our dependencies, then we'll run our application here, and as you can see, we just get a warning saying that we never actually used the match result. But what if we did cargo run, and then I'm going to put these two dashes here so that we're not accidentally passing any arguments into cargo. We want all of the arguments to be passed into our program. So we just use that double dash there to delimit any extra arguments that are going to go to our program instead of cargo. And then we'll do -- help. And you can see we don't really get anything here at this point because we're not calling get matches. So we actually need to call get matches right here, and that will invoke the parser and assign the parser results back into match result here. All right, so now when we do -- help, we should see a very basic help usage here. So it says what the binary name is, and then you see this positional parameter or argument right here called first name. And we don't currently have any names to reference this by except by first name, right? So this is what's called a positional argument. So normally what you would do is when you run your program, you would just pass in an argument, and whatever the first argument is going to be assigned to that first name argument in our match results. And that's because we've only declared a single argument, so therefore the first argument that we pass into the app is automatically going to get assigned there. Now, if we defined another argument, let's do dot on the command again and say arg, and then we'll say arg new, and then let's do maybe an ID of last name instead of first name. So now we have two positional arguments. Again, positional meaning that they don't have names. So let's do Trevor Sullivan. You can see that those get mapped perfectly fine. But if we try to pass a third argument, you can see that we get the help here because there is no third argument declared on our CLI tool. So again, these are what we call positional arguments because they don't have a short name or a long name or any aliases that we can reference them by. If you run other CLI tools like, cargo here, for example, if you do cargo run and do dash dash help, there's all of these named options that we have down here. So we could do dash dash release to do a build of our application in release mode. We could say dash dash quiet or the short name, which is dash q. But at the moment, we haven't specified either a short name or a long name to reference it by. So we're stuck using positional parameters for the time being. Now, if we want to, we could actually take these arguments and specify that they should have a name. So after we instantiate the argument itself, there's a whole bunch of additional methods that open up that we can use to customize the behavior of these individual arguments. So on this first name argument right here, we'll just do a dot, and you can see we get all of these extra methods right here. So one of the methods that's available here is called dot short, and this takes a character as input, and that's the short character, the single character that we can use to reference this particular argument. So that turns it from just being a positional argument to being a named argument with a short name. So what we'll do is just pass in a character like maybe F. So we'll do dash F for first name. And then down here, we'll do the same thing for last name. So we'll do short and say maybe L in single quotes there. And that L character will be used to denote a last name here. All right, so let's go ahead and do a help on this again. So we'll say cargo run dash dash and then dash dash help again. And now you can see under options right here, we no longer have the positional arguments. We now have a way to reference those individual arguments by using the short name that's assigned to them. Also, you can see that automatically without having to implement any code yourself, clap also does provide dash H and dash dash help and dash capital V, which is the same thing as dash dash version to get help and version information from your CLI tool. Now, if we tried to do cargo run and then specify Trevor Sullivan without specifying the short name of the arguments, now you can see that we can't use the positional status anymore because we've given our arguments names and it's expecting us to use those short names at the bare minimum, or a long name or an alias, which is kind of an alias to a long name. And so we can't just use the position anymore. So we need to change our syntax to call the CLI tool to dash F Trevor and then dash L Sullivan. And now you can see that it runs perfectly fine. So that's a really nice way to just give us a short way to reference these parameters. But let's say that you had conflicting first characters, right? So maybe you had an argument that says first name, but then you had another argument that's called Fluffy, right? So maybe we just copy this down here and say argument Fluffy. Well, if I try to do F as the shortcode for both of these arguments, that's obviously going to cause a conflict, right? So we actually get a panic here from our application, and it specifically tells us that short option names must be unique for each argument, but F is in use by first name and Fluffy, right? So that creates some ambiguity there that we can't deal with. So we need to use long names instead. So for Fluffy down here, I'll do dot long. And this allows us to specify a string that we can use to reference this parameter by. So we'll say Fluffy. We'll just use the same name as the argument ID itself. And then up here for first name, we'll do dot short, but then after we do dot short, we'll also do dot long. And this is what we call kind of a fluent syntax or method chaining, where we start calling methods upon methods, and it just keeps returning a new variant of the argument configuration. And so under long here, we'll do something like first dash name. And then for last name, we'll do long and say last dash name. All right, so now we've got some longer names. And if we do cargo run with dash F and dash L, that still works because we still have those short characters associated with first name and last name. But if we do dash dash help here, you can see that we also have the option to do dash dash first name, which is the long name for the argument, in addition to using the short name dash F. Same thing for last name, but Fluffy here only has a long name. It does not have any short name defined. So it's really nice that clap automatically takes care of printing out all the help and helping you to assign long names and short names using this very simple method syntax here. So I can easily look at some clap code and say, oh, here's an argument. It's a first name and it has this short and this long, right? Now we can also make this a little bit more readable. So as our code gets longer and longer and we start building out a much larger subtree of commands and arguments, we can actually just put all this on new lines because Rust doesn't care about the extra white space. So what we can do is just kind of indent these here a little bit to show that this argument has these indented methods that are being called on it. Same thing down here for last name. We'll just kind of indent these as well so we can see that those are associated with the indentation there. And then same thing down here, we'll just indent that as well. And that makes things a little bit more readable so we can just scan vertically through our entire application rather than having to do a lot of horizontal gazing. All right. I'm also going to put this .arg on a new line here just to be consistent with the other ones that we have down here. So that looks a little nicer. All right, so we've got short names and long names. And we also talked about the positionals, right? That's if we don't specify a short or long. We can also do aliases though. So if we do .alias or .aliases, we can either pass in a single alias or an array of aliases that we want to allocate to this particular argument. So if I do .aliases here, I can just do some square brackets to specify an array of values. And maybe I want to do something like fname. So fname is an alternative. And then maybe for last name, I'll do lname as an alias. So then I can do cargo run. And let's actually take a look at the help here really quick. What you're going to notice about the alias is that the alias doesn't actually show up. This is called a hidden alias because when we print out the help, we don't actually see the aliases printed out along with the help. So the hidden aliases are just kind of there to make your application easier to use because one person that's using your application might think fname, another person might think first name, another person might think first dash name, right? And so you can provide all of these different variants. So we can do first dash name, we can do first name with no dash, we can do fname, and no matter who's using our application, all of those names have the same meaning because they ultimately map back to this argument with an ID of first name. So some people are kind of against using aliases like that, but personally, I'm a huge fan of kind of usability. And so I encourage people, if you do have aliases that you think other people might interpret your application as using, then feel free to add those. Don't just say, oh, you have to put a dash in between last name. No, make it easy to use. So if somebody forgets to type the dash, or maybe they just don't think to use the dash, or maybe they're coming from other CLI utilities that follow a certain convention, you don't necessarily want your CLI to have to change conventions in their minds. And so by providing these alternative variants on the names of your arguments, it just makes your CLI that much easier for other people to consume, right? So I really like the fact that aliases are supported in the clap library here. All right, so we can also tell our clap application that certain arguments are going to be mandatory or required. Now, other languages and other frameworks have different ways of specifying this, but what we can do in clap is to say .required, and we can simply set that to a Boolean value of true or false. By default, it's false because you could see that we didn't necessarily have to specify Fluffy, right? We specified first name and last name, but we didn't pass in a value for Fluffy, and clap was totally fine with that, right? We don't have to specify a value for an argument unless we specifically designate that argument as being required. So all we do is call .required on our huge method chain here for our arg type. We could do that for last name as well. We'll say .required and just pass in a bool true, and Fluffy is not going to be required. So if we try to run our application and just specify -f, or let's try using one of our aliases like -fname, we can get an error here saying that last name was required. So we have to pass that in. And under the usage here, you can actually see that those two arguments were shown as mandatory, whereas Fluffy is not. Even though Fluffy still shows up in the help, it's not a mandatory parameter. So what we'll do is just say --fname, and then maybe use a different variant like last name Sullivan, And that works perfectly fine, right? We can use an alias for one argument, but we can use the kind of real name of another argument, and that works perfectly fine. We can also do just the short name like -l, and that works perfectly fine as well. We don't get any errors from the parser. So that's how we can mark a parameter or argument as mandatory. Now, something else that really helps is to have built-in documentation. And this is just another thing that's kind of taken care of for you by the CLAP library, rather than you having to implement all of this extra logic yourself. So what we can do if we want to kind of describe the purpose of an argument here. Now, first name and last name are pretty obvious, right? But when you start getting into different technology platforms, there's oftentimes some ambiguity around, what does ID mean? What does resource ID mean? What does name mean? These could potentially be kind of ambiguous arguments. So if you want to provide your users some clarity on exactly what those arguments mean, then you can specify inline help for each of your parameters, as well as the actual command itself. So on the individual arguments here, we'll say .help, and we can just plug in a string that provides a description of what that parameter is for. So we'll say the person's first name, and then down here we'll do .help and say this argument takes the person's last name, and we'll just go ahead and save that. That's all we have to do is just call this method called help on our argument objects. And now if we do --help, you can see that that description of each of those arguments is very nicely printed next to the argument short names and long names right here. So that's just a really nice way to provide some additional help to your users so they can kind of see what the intent of that particular argument is. Now, fluffy, honestly, is not very self-explanatory. What does that mean as far as a person goes? I don't know, but we'll just say, is the person wearing a fluffy coat or not? So, that can give some meaning to what fluffy is. Does fluffy mean that they have a fluffy dog? Does it mean that they have a fluffy jacket? Does it mean that they have fluffy hair? What exactly does that mean? So this allows us to give that argument some meaning, right? You could even use emojis in there if you wanted to. In fact, for coat right here, I'll just do a coat and insert that emoji there. And there, now we've got an emoji that helps to further visually describe the purpose of that argument. Sweet. Now, something else we can do with arguments is to actually make them conflict with each other. So let's say that a person has a first name or a last name, right? So for some reason, we're building an application where we only want to accept a person's first name, or we only want to accept their last name. It's up to them to provide either one, but we don't want both, right? So what we can do is use a method to designate that certain arguments conflict with other arguments in our application. This is actually really easy to do because once again, we just add a method on our argument method chain here called .conflicts with, and we can say it conflicts with all, which is basically going to be exclusive of any other arguments that we've defined, or we can just say conflicts with and then pass in an argument ID that we individually want to set it to conflict with. So in this case, we'll just specify the ID. So make sure that you grab the argument's ID, not its long name or short name or aliases. Make sure that you go to this ID field when you instantiate the argument and use that value. So we'll say that first name conflicts with last name. And so down here, if we do a cargo run and we specify both fname and -l, then we should get an error here saying that the argument first name cannot be used with the last name argument. So if we try to do just first name, then that works perfectly fine. We don't get any errors. If we do just last name Sullivan, that works as well, but we can't use them together because for whatever reason, we've made up a rule in our application that we want to take a first or last name, not both. So feel free to use that conflicts with method. And one of the reasons I actually do like this method chaining syntax here is because if you ever need to test something out, you can literally just comment out one of these lines and you don't have to change any other syntactical things here. That just takes out the period and the entire method call. So if you want to maybe just temporarily disable aliases and maybe re-enable conflicts or disable the help, you can just come in here and comment out those lines and play around with things. And then once you kind of figure out where you want to be, you can just uncomment everything and you'll be good to go. All right, now let's talk about another thing at the command level here. So far what we've done is we've done these global options at the command level. So we don't have any subcommands, we don't have any groupings of arguments or anything like that. But back at the command level, if we do a -- help right here, right now, we get the usage. So we have options, we have my clap test, that's my application binary name, based on my cargo project name, of course, and we can see our options right down here. But this doesn't really tell us what the purpose of this application is, right? So how do we tell our user that runs this application? Maybe they download a Docker container with our application pre-installed and they run the tool and it just prints out a bunch of help with a bunch of parameters, but it doesn't tell them, hey, what's the purpose behind this program, right? So what we can do is come back to the command level here, kind of the root level of our clap application. And there's this about thing that pops up right at the top because it starts with A. And what we can do is just plug in a string here, very similar to the help that we provide for the individual arguments. And we can just tell our user, hey, what is the whole idea behind this application? What do we want you to know about how to use this app, right? So we'll say this application registers people with their doctor's office, right? Maybe the purpose of the CLI tool is to register new patients at a doctor's office. Could be a whole bunch of other purposes, but let's just say that that's what it does for now. So if we do a cargo run, you can now see that the very first thing that's printed out from our application is this help message that indicates the purpose of our CLI tool, right? So that's another nice piece of metadata to have. Again, we can just put that on its own separate line here. So if for some reason we want to temporarily disable that, we can just comment it out and make our application more readable here. All right, so that's very helpful as well, but something else that I wanted to talk about is creating groups of parameters. So let's say, for example, that maybe first name and last name go together, right? That kind of makes sense that you'd have a first name and a last name, but let's say that you were having an application that both registers people with their doctor's office, but it also has the ability to register a pet with a veterinarian, right? So those are two totally different use cases, but maybe we have a single CLI that satisfies both of those use cases. So we want to be able to use first name and last name together, but if we want to register an animal, then we only want the pet name, right? So what we're going to do is create two different groups of parameters to our application. So we'll say .group, and we'll say person register, and then we'll do .group again, and this time we'll say dog register. So we have two different groupings of parameters that we might want to use for different purposes here. And I almost forgot, I also need to do an arg group here. So we need to import the arg group type, and then we can do arg group new, and then specify person register as our ID. And then we'll do the same thing for dog register right down here and close off that parenthesis. All right, so now we've basically instantiated these two new groups, but we need to make sure that our application knows that we want first name and last name to be registered with a specific group, right? So how do we accomplish that? Well, first of all, I'm going to comment out this conflicts with here because I want first name and last name to be used together. So what we can do is basically just append these to the group. So in the group configuration here, we actually have the ability to call methods on the group configuration as well. So what we'll do is say .arg, and this will add an argument to this group by name. So we could say .arg, and then we could say, all right, I want the first name argument to be added to my group here. And then I could do .arg again and say last name and append both of those arguments to this group. Now let's go ahead and define the argument for our dog registration with a veterinarian. So we'll go down here and just add in an entirely new arg here. And we'll call this arg new pet name. And under pet name, we'll just give it a long name of pet-name. And we'll give it a short of N for name, and that needs to be a car, so we'll use single quotes there. And we also want to set .required to true if we decide to use that. And then we want to add this pet name argument to our other group. So right up here, we've got our arg group. Let's put that on a new line, just so we see that indentation. And then we'll do .arg, and we'll pass in pet name. Now I ran into some issues with this, so this might not work exactly as I have it here, but let's give it a try and see if we can use those arguments together or separately. So we'll do a -- help right here. You can see we've got first name, last name. We've now got pet name here. And let's see if we can use first name with pet name, right? In theory, we shouldn't be able to, but let's do first name of Trevor and pet name of Cheyenne, which is my dog's name. All right, so it did seem like it allowed us to do that here. And I think the reason that might be happening is something to do with the ordering of the arguments here. Unfortunately, the documentation for CLAP is sometimes a little bit lacking, so I've had to kind of mess around with things a little bit. So I'm going to try to move those arguments right up after the group and see if that helps. Now we have the same effect right there. One other thing that you could potentially try is to come into the group and actually, I think you might be able to define an argument on the group itself. But anyways, the idea here is that we can kind of group different arguments together in our application and kind of make them exclusive to each other. So unfortunately, this particular demo isn't going to work. I need to kind of figure out what's going on with the syntax here. You can also do .group inside of the argument here. So let's do .group person register here for first name, and then we'll copy that and bring it down under last name. I wonder if that might actually fix this here. If it doesn't, then we'll go ahead and move on, but we'll try first name and pet name together again. And for some reason, it looks like it is still working. So unfortunately, this isn't going to work for now, but at least you kind of get the idea with groupings. You should be able to group certain arguments together in your CLAP application. Now let's talk about subcommands. Subcommands allow us to go up to our root level command right here and specify certain child contexts, right? So rather than using groups here, it might actually make more sense to say something like command register dog or command and then register person, right? So what we can do is define a new subcommand under our command context. So we'll say .subcommand, and then we can go ahead and implement a new command. So what we're going to do is use this command type, which is a capital C, not the lowercase command macro, but we want the uppercase command type. And then we'll do command and then say new, and we'll just give it a name, like how about register person. And let's put that on a new line right down here so we can see that child context. And now that we have this subcommand defined, we can start to define arguments on the subcommand. So what we'll do is actually we'll eliminate these groups here because we don't really need these for now, because we're actually going to be moving into child subcommands instead. And so I'll remove the group definition from that arg, remove it from that arg as well. And I'm just going to move both of these first name and last name arguments up into the definition of the subcommand. So rather than declaring the arguments on the global command, we're defining the arguments at the subcommand level. So when you drill down to a certain child context, those parameters will be the only ones available. So we're not going to see the kind of dog or pet related arguments, right? So we'll create a subcommand for registering a person. And then we will, let's see, what is this dot group for? Don't remember what that one was. Oh, that's for dog register. And then we will take the pet name here and we will move that into a separate subcommand as well. So after the first subcommand definition, we'll create another subcommand right here. We'll do command new, and we'll call this register pet. And then on the subcommand for the pet registration, we'll go ahead and just paste in the code for our pet name argument. Let's just indent these here a little bit so we can see that those belong to the argument. All right, so now we've got two different subcommands defined. We've got the register person subcommand with first name and last name, and then we've got register pet as a subcommand with just the pet name argument. And Fluffy is still defined at the global scope, so that could apply to either subcommand. But you'll actually see how Fluffy actually has to be declared before the subcommand is specified. So down here on our command line, we'll do cargo run and do -- help so we can see the difference in the help output here. Now, instead of looking under options for first name and last name, we now have these commands. We have register person or register pet. So when we do cargo run, we can say, all right, I want to register a pet. And when I do register pet, the pet name field or argument is going to be required, of course, because on line 30 here, the required method is set to true, meaning that if we call that subcommand register pet, then this argument is absolutely required, right? So let's do -- pet -name, and we'll say Cheyenne. And obviously that works perfectly fine now. Same thing for registering a person. If we do a cargo run register person, we're going to see that the first name and last name arguments are both mandatory here. And so this time we'll do -- first name. First -name is Trevor, last name Sullivan, and that compiles and runs perfectly fine. So that's how we can kind of separate our different functionality inside of our CLI tools into separate subcommands rather than using the grouping functionality, which for some reason I was having trouble getting working. All right, so now that we've talked about all that, let's finally talk about just how to retrieve some of the metadata from the application that we've built here. Actually, one more thing. I also told you that we were going to look at how Fluffy has to be used before we call our subcommand, right? So back when we did -- help, you can see that Fluffy is still an option that's declared at the global scope on our application. But what would happen if we tried to do at the end, after we call register person and pass in these arguments, what if we said Fluffy is true? Well, as you can see, we get unexpected argument Fluffy because Fluffy is not declared on the register person subcommand. It's declared at the global scope. So if we wanted to specify Fluffy, then we would have to do it before the subcommand context is entered. So at the beginning, we could say Fluffy true, and that's going to work perfectly fine because that's a globally scoped parameter rather than a parameter that's scoped at the, or I should say argument that's scoped at the subcommand level. All right, so finally, let's talk about retrieving data from the parsed arguments. So we've got this command macro that we've built out all this functionality, all these subcommands, all these arguments defined in each subcommand. We've got this about help for our application. There's a lot more functionality, so this is certainly not a comprehensive tutorial here on clap. It's just supposed to show you some of the fundamental concepts. But now we've got this variable that's coming back from this entire command structure called match result. And that's the result we get from calling the getMatches function on this entire command structure. So we'll go down here and we'll start to just print some information that gets parsed from our application. So let's do a print line statement here, and we'll print the match result. And then let's say .get1. So get1 is going to allow us to get the value of a specific option or a positional argument. Now, we don't have any positional arguments. We started off with them, but we turned all of our positional arguments into named arguments. So we shouldn't have any positional arguments anymore. But what we can do is specify an option name by its ID, and that should retrieve the underlying value for us. So right now we only have one globally scoped option, and that is fluffy. And if we try to retrieve that, then you're going to see that we need to unwrap the value because we have an option type here. And we also have to specify type annotation. So even though we're trying to unwrap the value, we still need to specify the data type that we're expecting the clap parser to parse this input data as. So what I'll do is use the turbofish syntax, which is a double colon, and then we specify our generic type name here. And this will be parsed as, let's say, a Boolean value. So we'll just do a bool there. And so this should return either true or false. So let's go ahead and just put in a prefix to say fluffy colon, and then let's run our application with dash fluffy true. And it looks like we are panicking here because fluffy was actually declared as a string type here. So I didn't actually specify that fluffy was going to be a bool when we declared it right up here. I actually declared it as a string. So let's just interpret it as a string right here. That's just going to be the default is a string value. So it just takes the string value. It could be true 2, true 3, doesn't really matter. It's just going to take the string value and return that as the value for fluffy. Now, let's say that we wanted to get a pet name, right? So we've got an argument up here called pet-name. So what do you think is going to happen if we try to get the pet name, right, as a string? So let's do pet name as a prefix, and then we'll try to parse the pet name and feed that into our print line macro call. So we'll do cargo run without anything else. We'll just do the fluffy true 3. And as you can see, we get a panic here because pet name doesn't exist at the global scope. If we want to get the value of an argument that's been defined at a subcommand level, not at the global scope, then we actually have to drill down into the subcommand itself in order to get that value. And something else that we could do here is say .unwrap, or we could say unwrap or, and then provide a default value if we get an error. So that could prevent the panic from occurring. So we'll just say no pet name in capital letters so that it's really obvious. And then we'll do .toString because it's expecting a string value. And it looks like it's looking for a borrow of string. So let's go ahead and I think we can put a deref in front of that maybe. Let's try dot as pointer. No, it doesn't like that either. So let me see if I can figure this out really quick. All right, so by putting our borrow right here, right before the string itself, that seems to resolve our type mismatches there. So let's try this again. And it looks like we are still having an issue here. And this is probably because the actual pet name field itself isn't even recognized, right? So what we can do is actually drill down into the subcommand scope. So if we take a look at match result right here, that's referring to the global scope of arguments. But then if we go into match result and then do dot subcommand, we can actually match to a specific subcommand. So what we can do is say, what is our subcommand name? And we'll do that as just a static string value. So we'll say, is it register pet? And if it is, then we can just assign that result. We'll say let pet args equal the result of that. And then we'll have this option that points to an arg matches. So then we can do a semicolon at the end, of course, and we do pet args dot, and then we have all these functions that allow us to interact with, well, this is the option, so we'll say unwrap, and then we can say, does it contain the ID of pet name? So this is going to return a Boolean value, and we'll just say print line, does pet name exist? Question mark, and then we'll pass in either true or false as the result from that contains ID function there. So then we'll do cargo run again, and we're trying to unwrap on a none value, and that's happening because we are not actually calling the subcommand, right? So what's happening is we're trying to unwrap this value here, and it doesn't exist. So we're going to, in this case, call cargo run, register pet. And so now it is being kind of parsed correctly here, but we didn't actually specify pet name. So technically we can unwrap the arg matches object here because we did call register pet, but we are not getting a result on the pet name here. So what we'll do is say register pet and then pet name, and we'll specify Cheyenne as the value. And now it says, does pet name exist? Yes, it does, because we specified that argument. So how do we get the actual value of it? Well, this is where we can do the dot get, and then we'll say get one. We'll do a parse with the turbofish syntax into a string value, and then we'll specify pet name as our input here. And then we need to unwrap that value as well, because it gets returned as an option type. So if we run that, it says, does pet name exist? And it gives us the actual name this time of Cheyenne. So we can do kind of the same thing with the other subcommand. So if we want to register a person, then we can say let person args equal the match result, and then go to subcommand matches. And this time we want to match register dash person instead. And we'll try to unwrap that value. And then we'll say print line, first name X, and then last name Y. And we'll pass in person args dot get one. And we'll say, I want to get the first dash name. I think that's our ID up here. It's actually no dash, so we'll take that dash out. And we also want to unwrap that value. And then same thing for the last name. We'll say person args dot get one, and we'll specify last name. And then of course, we're also going to have to use our unwrap here so that we can retrieve the underlying value. And then it's going to need type annotations once again. So let's just do a turbofish syntax here. We do have other options. Like for example, we could say make a local variable down here, like let fname equal a string. So we'll say string as the type. And then the Rust compiler can actually infer based on what's on the left-hand side here, what kind of type it should return. At least I think it should be able to. But using the turbofish syntax seems a little bit more consistent in this particular case. So let's update this to use the turbofish syntax here, and we'll remove the string from over here. This is just the compiler kind of inferring the type here. It's a borrow of string type. And then we'll pass fname in right here. And then we'll also do the same thing for lname. We'll say person args.get1, specify string as our type, and then we should be able to pass in lname. All right, so then up here, we'll go ahead and just comment this out for now. You could do an if statement to kind of check to see if it successfully matched register pet or not, but for now, I'll just comment it out. And now if we do a cargo run and say register person, and then do dash dash first name, Trevor, last name, Sullivan, we can see that we were successfully able to parse and retrieve those values from our CLI arguments. So anyways, hopefully that was a useful introduction to CLAP, and hopefully you can get started with the builder pattern. Just remember that there is the attribute pattern as well, or the what they call the derive pattern, that is not quite as easy to use in my experience, but hopefully you'll at least be able to use this builder pattern to declare your arguments. And hopefully I'll be able to figure out what's going on with that grouping functionality so that we can actually get that working in a future video. But for now, go out and build your own applications using the CLAP parser, because it does really provide a nice syntax to get your arguments parsed, your subcommands parsed, and then you can implement whatever functionality you want to use to actually take those arguments and process them. Thanks again for watching my channel. Please leave a like on the video if you learned at least one thing new. Please subscribe to the channel and hit the bell icon so you get notifications about new videos. Please also leave a comment and let me know what you thought of this video and any suggestions you have for other Rust topics, and we'll see you in the next video. Take care.